Hello and welcome to this video lecture presentation on domain and range. What is domain and range? Well, let's first start with domain. Domain is the set of x values that a graph is made up of. So what we're going to be doing is we're going to look to see if there's any beginning and ending points. We're going to scan left to right to see if they're starting x values, ending x values, or if they just go on forever. And then we're going to indicate our solution in our final answer. The range is going to be the set of y values that the graph is comprised of. So let's see what I mean. So this problem right here, I wanted to determine the domain and range, and then I want to determine f of 1 and any values of x for which f of x is equal to 2, and I will explain what these mean. All right, so for domain, it's a set of x values. So I'm going to scan left to right. Here's my first point right here. What is the x value that corresponds to that? So domain starts off at -2. Now we keep scanning. Do I have an ending point on this graph? Yes. What's my ending y value attached to this starting point? -3. Now we're going to keep going up. Is there any ending point? Yes, there is. What is the y value to that corresponding endpoint? 4. So now let's determine what's f of 1. What does that mean? That means that I'm plugging in 1 in for x. So when x is equal to 1, what's y? So where's my x of 1? Right here. So where is the graph when x is equal to 1? Right here. So what is y when x is equal to 1? -2. That's this value right there. Now, what we're asking is when y is 2, when our y value is 2, what is x? Well, where is 2 on our y-axis? Right here. So we go over to meet up with our graph. That's right here when y is 2. What's the corresponding x value? 4. So our answer is 4. So when f of x is equal to 2, or we're saying when y is equal to 2, x is equal to 4. Let's look at another example. Okay, so let's look here. Let us first find the domain of this right here. So I'm going to scan left to right. Do I have any starting point? Right here. What is the x value that corresponds to that starting point? -4. Now I keep scanning. Do I have any ending points? Yes, I do. Right here. It's my ending. What is the corresponding x value at this ending point? That is 2. Now the range, you scan from the bottom up, and we look for any starting points, or if it just keeps going on forever. Because if you have arrows, that indicates infinity. But let's work this out first. So scan from the bottom up. Do I have any starting points? Right here. What is the y value that corresponds to that starting point? -3. 2. Now do I have any ending points? Right here. What is the corresponding y value to this ending point? It's 3. So now let's look at what is f of 1. What does that mean? It means when x is 1, what is y? So when x is 1, where's my graph? Right down here. What's y? -2. Now it says f of x is equal to 2. So what this is saying is when y equals 2, what's x? So locate y equals 2, that's right here. Well, what is my x at y equals 2? Minus 2. X equals minus 2 when y equals 2. And that's how you do that, these types of problems. Okay. Now I'm going to probably tailor one of these problems to show an arrow. So we'll pretend that there's nothing. We'll have something like that. We'll do this one last. Okay, so what we want is the domain. What is the set of x values? So we go from the left. Here's our starting point. What's the x value that corresponds to our starting point? Minus 4. 2. Scan, what's our ending point right here? What is our corresponding x value at our ending point? 3. Now let's get the range. Go from the bottom up. Here's my starting point. What's the y value associated with that starting point? Minus 2. Now notice we go all the way up here before we end. You want to include the full range of values that y is. So in this case, we don't want to look at the ending point because then we're going to be shortchanging a couple of other points that this graph is made up of. So here we go to the very peak. What is the very peak? Right here. What's the corresponding y value? 5. So now when f of 1 is equal to what? What are we saying here? We're saying when x is 1, what's y? So where's my x of 1? Right here. What is my y at that point? Go over, and that's 3. And then we're asking, okay, what is my x when y is equal to 2? So y is equal to 2 is right here, and here's my x value, minus 3. So our x equals minus 3 when y is equal to 2. And that's how you solve that. Now let's look at determining the domain and range of this. So we scan left to right. Notice I have arrows. That indicates infinity. So our domain is from minus infinity to infinity, because this is an arrow that indicates that just keeps going on forever. So if you extend it out forever, that's going to include all of these minus values. And then let's look at what the range is. You scan from the bottom up. Do we have a starting point? Yes, we do. Our y is 0, right? Y is 0. So 0, 2. And then this is just going to keep increasing upwards like this will, up to positive infinity. And that's how you solve that. When we want to determine what's y when f is 1, or when x is 1. So we look where x is 1, move it up, our y is 4. So f of 1 is equal to 4. Because what is this saying? When x is 1, what's y? When x is 1, look where the graph is at that point. What's y? 4. And then when f of x is equal to 2. So we look where y is 2. That's what this is saying. When y is 2, what's x? Bring it over, it'll be minus 1. X will be equal to minus 1. And that will, one more thing is, the easiest way to determine domain and range is not to look at it from an equation. Where it's like f of x is equal to 3x plus 7 or something like that. You want to actually graph it so you can see it visually. What is the domain? What is the range? So if you're ever asked this in other math classes and you're given the expression for it, graph it, and then from the graph determine the domain and range. And you'll have a much easier time solving it. But that will conclude our discussion on domain and range. Thank you so much for listening and watching. I hope this was easy to follow and understand. Thank you and have a good one. Bye-bye.